right. And this short one, I hope it's going to be short. I want us to look at the proportionality theorem, the theorem in Euclidean geometry for grade 12. The theorem says a line drawn parallel to one side of a triangle divides the other two sides in proportion. What this theorem tells us that if PQ there is parallel to BC, that is these two lines, then A P over PB will be equal to A Q over QC. That is AP over PB will be equal to AQ over QC. This can be written upside down to have PB over AP will be equal to QC over AQ. And the reason for that, the reason that we give for that proportionality, that will be line parallel to side of triangle, or the short one, prop theorem. But this one now you have to state the lines which are parallel in that, the lines creating the proportionality. So this is PQ parallel to BC, right? This proportionality can be written in several different ways. Like you see, I've written it in two different ways here. We could have this one also. We could have it as AP over AB is equal to AQ over AC. That is AP over AB, that is this smaller side divided by the whole side, over AQ, the smaller side, divided by the bigger side. And this also can be turned upside down to be AB over AP, that is equal to AC over AQ. All right. We can come up with another one. Here I've used the smaller side divided by the whole side. You also can use the smaller ones here down here, so that will be PB over AB is equal to QC over AC. That is PB, the smaller one here, divided by the whole side is equal to this smaller one divided by the whole side. And then you can turn this upside down also to have AB over PB is equal to AC over QC, right? And for all of that, this you give one of these two reasons: line parallel to side of triangle. You can actually remove this off, or you can also give proportionality theorem where PQ is parallel to BC. If you are giving this proportionality theorem reason, you should include the lines which are creating the proportionality theorem, right? If you remember from grade 10, you had what we were referring to as the midpoint theorem. Midpoint theorem is a special case of the proportionality theorem, right? It's a special case because it's only dealing with the midpoints, right? So if we have A, B, C, D, E, the midpoint theorem was saying a line through the midpoint of a side parallel to the second side will divide this third side into, or will bisect this third side. And the reason we were giving there, line through the midpoint parallel to a second side, right? That is the special case of the proportionality theorem. And the ratio there, you should see that we have ratio BD over a G there. It's 1:1 because it's a midpoint there. This side is equal to that side. So the ratio there will be 1/1. We can write this as BD as 2AD, and that is equal to 1:1. So you can write it this way, you can write it that way, right? All right, let's look at how we can use the proportionality theorem in answering questions. This is the first one, given triangle EDF. In this triangle EDF, we have DG, there is X, GE, 16 centimeters, EH, 24 centimeters, HF is 9 centimeters. How do we determine the value of X in this circumstance? We have a pair of parallel lines here, so we can talk about proportion. So, stating the proportionality theorem there, we have that DG over GE is equal to FH over HE. And the reason there, prop theorem with GF parallel to GH. Now substituting into the proportionality theorem there, we have X over 16. X over 16 is equal to 9 over 24. Now to get the value of X, take your 16 to the other side. X is equal to 9 times 16 over 24. And this will give us 6 centimeters. So this is 6 centimeters here. And then the second question, you can pause, go through the question once again, digest it so that you fully understand it. Now, for this one, we have proportionality theorem once again, because in the triangle we have this line parallel to the other side of the triangle. So we are saying we are given a full side here. We are given a full side, so we can write that one which includes the full side. And on this side, our full side there is 28 plus 12. What do we get if we add 28 to 12? 28, 30, that is 40. So your QR there is 12 plus 28, that is equal to 40. So our proportionality theorem there will say PS over PR is equal to QT over QR. You see, I'm writing the smaller side that we are looking for divided by the whole side is equal to that smaller side divided by the whole side. And the reason, prop theorem with PQ parallel to ST. Now substituting there, our PS is X and our PR is 30, and that is equal to 28. Therefore QT over, we said QR, we add these two to get 40. So your X there is equal to 28 times 30 over 40. This is 3 over 4. And that gives us 21 units. And then let's look at another question. All right. Hey, this one is full of X and X and X. we do that? All right, the easiest way here, since you are given the longer side and the smaller side, you need to determine this one by subtracting. You subtract the smaller side from the longer side. So we have x plus 11 minus in bracket x plus 5. So x minus x is a 0. 11 minus 5 is a 6. So we are saying here we have a 6. We can now state our proportionality theorem there. We have AB over BD is equal to AC over CE. That is equal to AC over CE. And our reason, prop theorem with BC parallel to DE. BC parallel to DE. Just remember, you need to state the parallel lines if you are saying proportionality theorem. If you do not want to do that, just say line parallel to side of a triangle. Now substituting there, x plus 5 over 6 is equal to x, this is 5x minus 3 over 3x. And then we need to solve for x here. Take your 3x to the left. 3x cross multiplication there, x plus 5 is equal to 6, 5x minus 3. This is 3x squared plus 15x is equal to 30x minus 18. And then collect everything to have 3x squared, and then 15x minus 30x, we have a negative 15x there, and then we have a negative 18 that gives us a positive 18 that is equal to 0. We can divide through by 3 here, common factor there, so we're left with x squared minus 3 into this one is 5x, and plus 6 is equal to 0. We can use factorization here. This should be x plus, we have 3 and 2, x minus 3 and x plus 2, that is equal to 0. So your x here is going to be equal to 3, or your x is equal to 2. All right, I did not factorize correctly here. We have a negative 6. We have a positive 6 here, so both of them are negative, so it's negative 3, and x is negative 2, that is equal to 0. So your x is equal to 3, or your x is equal to 2. So one of those two values will give us the correct x. All right, and then this should be my last question there. In the sketch alongside, it's given that PF is parallel to DE and BG is parallel to DF, BG parallel to DF, AF is 60 centimeters from here to there, 60 centimeters, and then the ratio there, we're given this as a ratio, but we can also write it as a fraction as AB over BD is equal to 7 over 8. And then this one, divide both sides by FE, you are going to have AF over FE is equal to 3 over 2. All right. Now let's use that to determine the length of these given lines. The first one is FE, this one here. How will we do that? We are given that F making use of this one, AF over FE. That is AF FE. This is 3 over 2. We can use that ratio. This is the same as, okay, let's use variables here. 3x over 2x. We cannot say this is equal to 3 and then this is equal to 2, right? Because that 3 is not equal to 60. But that 3 is multiplied by something to get that 60. We want to get that something. So we are saying where we have AF here, according to this ratio, is 3x. So this is 3x and this will be 2x. That is the ratio that we are given here. So AF as to FE or EF is 3x as to 2x. This 3x is equal to 60. We can equate that to get that x. So we are saying 3x is equal to 60. Your x then is equal to 20 there. If our x is equal to 20 here, what is the value of, what is the length of FE? Now our FE should be equal to, from here, our FE should be equal to 2 times 20. So FE is equal to 2 multiplied by the value of x there, that is 20, that is equal to 40 centimeters. So let me get rid of this 2x to make my life easier. I'm writing it there. So this is 40. So we now have the ratio here, this ratio here. We can now write it as 60 over 40 there. That is the new ratio that we can consider also. Now the next question, AG. This is AG here. How do we determine AG? We can use proportionality theorem there. We are given, we use this one. AB over DB, that is 7 as to 8. Please consider these parallel lines. These parallel lines, they are covering AF there. All right? So we can say AG over AF. Let's do that. So we are looking for AG, and we can say AG over AF. AG over AF will be equal to AB here over, here we said AG over AF. So this side will say AB over AD. Your AD here is the sum of these two, that is 7 and 8. This is just a ratio. So we will write it as AG, that's the one we are looking for, over AF there, it's 60 centimeters, and that is equal to the ratio on this side, AB, is a 7 over 7 and 8, they give us AD, that is a 15. So your AG, okay, we did not give a reason here. Prop theorem with the parallel lines, BG parallel to DF. You should never forget that. So AG here is equal to 7 times 60 there, divided by 15. 15 goes into 64 times, and then if you multiply by 7, that gives you 28 centimeters. So we are saying AG here is 28 centimeters. That is AG. Let's go to the next question. If AB is 21 centimeters. All right, I want to put that in the diagram there. So we are saying if AB is 21 centimeters there, determine AD. Determine AD. You remember this ratio? AB over AD, right? Let me use the method of, we can use that method of variables here. We are saying AB. Which question are we doing? This question here. We can say A B over A D there. AB over AD, that is AB over AD. This is going to be 7 over 7 plus 8, that is 15, right? And that is our x and our x. And then this should be equal to, we have a 21 here, right? So we can say we go to 21 over the whole AD. Do we have AD? That's the one we are looking for. Ne? We do not know the value of AD. But on top here we have 7x is equal to 21. And then 7x over 21, you can see that your x there is equal to 21 divided by 7. That is equal to 3. So your AD is equal to 15x there. So AD should be equal to 15 times your x is 3 there. So your AD is 45 centimeters, right? AD is 45 centimeters. We could also do it a different way. Okay, let's use that proportionality theorem here. We are looking for AD, so we can say AD, that is AD over AB, is equal to AF there, AF over AG, and we have prop theorem with our parallel lines BG parallel to GF, and then substituting there your AD over AB. AB is 21 there, that is equal to AF, it's 60 centimeters, and then AG we saw that is 28 centimeters. So your AD, take this 21 to the other side. AD is equal to 60 times 21 over 28, and that is equal to 45 centimeters. So this is another way you could have done this same question. And then the last one is BC. Let me create some space there. How do we get BC? Let me clean the diagram also a little bit. I do not want this one anymore, but I do want AB. This is the part I am looking for. Just this BC here. That's the only one we are looking for. How would we get that? We can calculate AC, right? So if we are to use AC, we will have that BC is equal to AC minus AB. We do have this AB being 21. So we can calculate AC and subtract BA to be left with BC. Now, how do we get our AC here? You should notice that AC over AD, we do have AD, né? And that is equal to AF over AE, and our prop theorem with the parallel lines CF and DE, and then substituting there, your AC is your AC over 45. We saw that AD is 45, and that is equal to AF, it's a 60 there, and the 60 over AE. AE is this whole side, so we have 60 plus 40, that gives us 100. So your AC then is equal to, your 45 goes to the other side, is 60 times 45 all over 100, and this should give you 27 centimeters. And remember, we said AC minus AB. Our AC there is 27, our AB is 20 minus 21. So this should be 6 centimeters. All right, that's all I have for you.